Hello friends, my name is Joker and today I'm going to teach everybody how to make a digital clock like what you see right here that shows the number of minutes and the number of seconds. So first I want to show everybody what the problem is that we start with. So normally what you have with gadgets in Rec Room is a timer chip will output just the number of seconds remaining in the timer. And if you output that to a sign, what you get is just the raw number of seconds. In this example, we have 80 seconds, which should be 120 minutes, but that's not very useful when you're playing a game. It can be kind of confusing. So that's what the circuit that I've been working on is for. And I'm going to show you, let's go to Facecam first of all. So I'm going to show everybody how to build that, but before we do, we need to learn a little bit about a couple of the combinator chips, specifically the division chip right here and the modulo chip. I'm going to explain how they work. Some of this is some basic math. Some of it is specific to Rec Room. If you're already familiar with the division chip and the modulo chip, I'm going to try and put a link in the video to just skip ahead to building the circuit for the digital clock, so you can feel free to do that. But for the rest of you, I'm going to start out by explaining the division chip. So division is pretty straightforward, except for the fact that this symbol is sort of, maybe this is right for computer scientists, but for the rest of us, it's kind of weird. It's just a slash. But the way division works is mostly how you'd expect. I've got a variable chip out here defining two numbers, and as you'd expect, if you put in something like 35 divided by 7, in the real world, that's 5, and right here, as you can see, the division chip does that correctly. Another example is something like 24 divided by 6. That's 4, and it gives us a 4. So that's all as expected, but let's go back to 35 for a moment here. The weird thing, for non-computer scientists at least, the weird thing about the division chip is that normally division, the way you learned it in elementary school is division gives you the number of times a number can go into another number, and then a remainder. Okay, so 35 divided by 7 is 5 with a remainder of 0, right? Now in Rec Room, the thing about it is there's no such thing as well, there is such thing as remainder, but as far as the division chip is concerned, there's no such thing as a remainder. So in the real world, 36 divided by 7 in decimal form would be some weird number, but it would be 5 remainder 1. But as you can see, the output of the division chip completely forgets about remainder. 36 divided by 7 is just 5. And that's true until you get to another factor of 7. So 39 divided by 7 is, it should be 5 with a remainder of 4, but again, it's still just 5. Once we get up to, 42? There we go. 42 divided by 7 is 6, remainder 0. But any bit less, it just totally forgets about the remainder, okay? So that's actually going to be important specifically when we're building the digital clock, and you'll see that in a minute. This is also important for for just generally working with the division chip in Rec Room, and the way I want to really drive this home is Rec Room is a very special place where 999,999 divided by 1 million equals 0, okay? That's how I want you to remember that. Because anywhere else, this would basically be 1, a little less than 1. But in Rec Room, it's the same thing as 0. So, I think that's all for that. So now let's talk about the modulo chip. Modulo is kind of something you don't really come across until you're in advanced math in school, but it's actually not really that complicated. There's two ways to understand it. The technical definition, and the most important thing for the digital clock, is that modulo is the remainder after division. So I talked about how the division chip is only the It only gives you the number of times something goes into something else, and it forgets about the remainder. Modulo chip's kind of the opposite. It doesn't care how many times one number's gone into the other. It just cares how much the remainder is afterwards. Okay, so like anything else, I should have turned notifications off, shouldn't I? That's all right. Make sure this is going right. Uh-oh. Yep, we're good. And the way these work, I should have said in the first place, is it's always red operation green. So this is red divided by green, and this is red modulo green. So the way I have this set up right now is 35 modulo 7, and the other way of saying that is the remainder after dividing 35 into 7. Right? So 35 divided by 7 is 5, remainder is 0, and that's why the modulo chip is outputting 0. But if I start to add on to the first number, you start getting the remainder. 1, 2, 3, 4. Yep. 39 divided by 7 is 5, remainder 4. And that's all right in front of you here. And for those of you who are really paying attention, this is going to be basically how that clock ends up working. We'll see that in a minute. The other thing to keep in mind with modulo chips is, I'll demonstrate this right now, as we approach the next factor. So this is modulo 7, right? 3, this goes 3, 4, 5. It's all the possible remainders up until we get to the next factor. So 6 is the highest possible remainder. And then once we get to 7, the remainder is 0, because now you've just got a full group of 7. And the way that's kind of useful for a lot of things is a modulo chip can sort of function like a cycle. You're cycling through the number that's defined by the second number, the modulus, I guess. So you can just, this is good for iterating through something and just sort of counting in a circle. 1, 2, 3, 4, 5, 6, 0. 1, 2, 3, 4, 5, 6, 0. The other way to explain this is kind of like a 24-hour clock that they use in the rest of the world that's not the US, where you get up to the 23rd hour, and then there's no such thing as a 24th hour. It's just midnight. You go from 23 to 0. So 22, 23, 0, right? Or if you really want, it's kind of like getting up to 12, and then you go back to, from 12 you go to 1, but that gets kind of confusing. Okay, so those are those two chips. I think I said everything I want to say about those. Yeah. Okay, so now we're jumping back into where I can explain how to turn this clock, which is just a raw number of seconds, into this clock, which shows a display of minutes and seconds. You can also do hours by the same strategy with a few more chips, but if you're making a game that takes a number of hours, then good luck. You've probably got a lot more to worry about. So the starting point is we've got the number of seconds, right? It's 80, and you can see that by hovering over here. And we know that 80 seconds is 1 minute, or is 1 minute and 20 seconds. But the way we tell Rec Room that is to get the number of minutes that belong to 80 seconds. Wait a minute. This isn't how I want to do this. I'm going to jump over here. I'm actually just going to start by, okay, we're going to build this together. So I'm going to spawn a timer chip first of all. It's going to take a little bit longer, but you can see all the steps. Make sure you understand how it works. So I'm going to set up this timer chip to, so it's going to be powered by the state machine over here. It's turned off right now, yep. The number of seconds in this timer chip is going to be 80, which is measured in tenths of a second, so you have to put in 800, right? So that's 800, and there's 80 remaining. Now, do an output chip just for good measure, so we can really see what's going on at each step of this. All right, so the timer's not running right now, so it's just outputting the number of seconds remaining at the start, which is 80. And let's get the sine prop out here just to have it ready. So, let's start with the number of seconds. Let's start with the number of minutes. So the number of minutes in 80 seconds is the number of seconds divided by 60. So get a division chip by spawning a combinator, configure it to be a division chip. There are no bugs in this game. So we're going to do 80 divided by, let's put our variable chip up here because that's how I like to do it. It's going to be 80 divided by 60. And if I put a, oh, didn't mean to do that. Put an output chip right here. Hang on a second now, what am I doing wrong? Oh, I put the 60 in the wrong place. Oops, okay. 80 divided by 60 is not 1, but as we talked about over there, it's 1 and some remainder, and because this is a division chip, it forgets about the remainder, which is actually kind of convenient. So it gives us a number of minutes and forgets about the number of seconds. So we've got 1 minute. And for those of you, this is a refresher on signs as well. To output a number into a sign, you use the format of curly bracket R. Let's actually just go ahead and start out and put in the format that we're looking for, okay? Because, spoiler, I'm going to be using the green pin to take the number of seconds remaining. So it's going to be red pin, colon, green pin. So right now it's 0, 0 because it's got no input. Input there, and it's 1. So right now it's 1 and 0, and we will deal with that in a minute. And as you may have guessed, hopefully, to get the number of seconds remaining in the current minute, we get the remainder. It forgets about the number. If you take 80 and divide it by 60, you get 1, and then some remainder, and the modulo chip is how we get that remainder. So, and conveniently, we already have this number 60 here in the variable chip, so we can just reuse that. Let's move this over to make it a little bit more clear. All right. So now the number of seconds, modulo 60, should be 20. And it is. Because you go through 60, and there's 20 left over to get to 80. And let's, again, just for consistency, put this on a variable chip, but it's also going to go up here. So there you go. And that's most of the work. There's 1 bit left. And it's not obvious at first, but yeah, so we've got the number of minutes and the number of seconds. The one thing remaining is, press my button here to start the clock. This is going to start counting down. The problem is, once it gets to less than 10 seconds, it drops down here. The format is not exactly what we want. Oops. And the way to solve that is you can use a different message in the sign, because the signs allow you to do up to 5 different messages, 0, 1, 2, 3, 4. What we want it to end up looking like is, I think I'm forgetting minutes, seconds. Yep, okay. What we're going to use is a similar format, but we're just going to put a dummy 0 in there before our number of seconds. So when the number of seconds is only 1 digit, you'll have a 0 before it. That's what we want to get to anyway. So, move this over here. The way you change a message in a sign is you send that number, the number of the message that you want, into this light blue pin, right? So right now it's getting a 0, and message 0 is just our normal R:(G) format. And then I've wired this button just for demonstration up to the green pin, and for those of you who know how the buttons work, when the button's held down, the green pin just sends out the number 1. So this is going to change it to message 1. So that's what we want. We want it to say 105 instead of 15. And the question is, how do we get the number 1 to be sent to this light blue pin only when the number of seconds is less than 10? And the answer is using a compare chip, a simple compare chip even. So compare chip, the condition it defaults to equals, but we want the condition to be less than. And like everything else, it's red operation green. So red less than green will send a 1 to the true pin if red less than green. So condition we're looking for is the number of seconds. So hook it up to right here. This is our modulo chip outputting the number of seconds. And then we want less than 10. So go up here to our variable chip and we have exactly the number of free pins that we need. Oh, but I did it wrong. Yes, I did. There we go. I want the blue pin. Okay. So that's 10. Great, so when the number of seconds is less than 10, which it currently is, because this is 5, it should be outputting a 1. So come up here and connect that. 105. And that is pretty much it. And let's, for the sake of being really sure, I'm going to reset this. Reset the timer. And we will watch it work. So this says 120. And it's going to count down, and we're just going to listen to some music for 10 seconds. And 09. That's all of it. You can set this number of seconds to whatever you need, and it up to an hour, it's going to look fine. Even above an hour, you'll just get a weird number of minutes. And that is how you build a digital clock. Thanks very much for watching, guys. I will see you around.